So till your 10th standard, you have heard that octet rule indicates stability. That means if an atom is having 8 electrons in its outermost shell, it becomes stable. That follows, that same thing follows in a molecule as well. Like see, for example, you are having CH4, and then you say that CH4 carbon is having 8 electrons in the outermost shell, I mean 4 of its own, and 4 it is sharing with hydrogen. Okay, that's how you say that the octet rule is being followed. Carbon is having 8 electrons in its outermost shell because it is sharing 2 electrons each with hydrogen. So hydrogen is completing its duplet and carbon has completed its octet. That's what we say when it comes to molecules. But to be very honest, this is the primary information. So chemistry has evolved beyond the octet rule also. So this is the octet rule, but later on we understand in our 11th standard that there is a topic called as failure of octet rule. Okay, the octet rule is not the ultimate information which we are having to explain the stability of certain molecules, because there are certain molecules whose stability cannot be explained by octet rule. Okay, now say for example BeCl2. Okay, BeCl2, let me draw its structure. BeCl2, this is called as incomplete octet. What it is called as? Incomplete octet. Okay, so it's showing incomplete octet. Why? Because you know that beryllium has an atomic number of beryllium has an atomic number of hydrogen, helium, lithium, beryllium 4, 2, 2. So it is having 2 electrons in its outermost shell, one over here, and one electron is being shared by chlorine. So if you have a look at the outermost shell of beryllium, it is not having 8 electrons. Okay, it is not having 8 electrons. It is just having 1, 2, 3, 4 electrons. And octet theory or octet rule cannot explain the stability of BeCl2. ऐसा नहीं है कि BeCl2 unstable है. BeCl2 is very much stable, but the stability of BeCl2 cannot be explained by octet rule. Okay, so how do we explain the stability? Sir, you must be thinking that sir छोड़ दो ना, एक आधा exception है, छोड़ दो इसको. But this is not the only one. Okay, I can show you another example, that is BF3, boron trifluoride, wherein again we are able to see incomplete octet. What are we able to see? Incomplete octet. Boron with an atomic number of 5, electronic configuration 2, 3. It's having 3 electrons in the outermost shell, 1, 2, and 3. One electron is being shared by fluorine. So if you see, the outermost shell of boron is having just 6 electrons instead of 8. So again, you can see over here the octet theory is not able to explain the stability of BF3. This is called as incomplete octet. But now let us see expanded octet. That means it's having more than 8 electrons. Okay, so for that we'll take an example of PCl5, phosphorus pentachloride. So phosphorus having an atomic number of 15 with an electronic configuration of 285. If you are well versed or acquainted with the newer way of writing the electronic configuration, then it will be 1s2, 2s2, 2p6, 3s2, 3p3. Okay, so over here also you can see that in the third shell, that's the outermost shell, is having 2 plus 3, 5 electrons. So 5 Cl are getting attached over here, 1, 2, 3, 4 and 5. Okay, so you are having 1, 2, 3, 4 and 5 electrons of phosphorus sharing one electron from chlorine. Okay, so here you can see that there are a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons in the outermost shell of phosphorus. So they are also more than 8. Again, it's not octet rule is not able to explain the stability of PCl5. It is having 10 electrons instead of 8. Same goes with SF6. Now in case of SF6, sulfur will have 12 electrons in its outermost shell. Okay, whereas octet theory says that it should have 8, then only it's stable. But here you can see that they are having more than 8, less than 8, still they are stable. So then who explains the stability of these molecules? Who can explain the stability of these molecules? So we had to discard the octet theory and introduce a new theory, that is the hybridization theory. So in this hybridization theory, we are considering the mixing of orbitals. What are we considering? We are considering the mixing of orbitals. So hybridization itself means mixing. Now for the first example, let us consider BeCl2. Now in beryllium chloride, we have seen that beryllium was having an atomic number of 4 with an electronic configuration 1s2 2s2. So if I write 1s2 2s2 like this, 2s2 will be having, S is having one orbital with 2 electrons in it. Then in ahead of 2s2 we are having 2p, but that's having 0 electrons in it. So what is the electronic configuration? How do we go about it? 1s2 2s2 2p6 3s2. But here, the moment we have entered in the second shell, we are having access to the 2p sub-level, but it is having 0 electrons in it. So here is your 2p sub-level with 3 orbitals, px, py and pz, and this is your 2s, and these are your 2px, 2py, 2pz. So now what's going to happen is, what cannot be explained, what could not be explained by octet, we are trying to explain by hybridization theory. So what is going to happen is, this electron is going to shift to from 2s to 2px, and the moment it shifts from 2s to 2px, the energies of both the orbitals become equal or similar, and they combine with each other, they overlap with each other. Who? The s and p orbitals. See, never before has s and p orbitals come together. Like s is having 1 orbital, p is having 3 orbitals, d is having 5 orbitals, and f is having 7 orbitals, isn't it? So now can you see anywhere 2 orbital structure over here, or 2 orbital? There are no 2 orbitals. We are forming 2 orbitals by mixing. So we are doing something new. We are doing something new by mixing of 2 orbitals, that is s and p. So s and p, 1 electron is already here and 1 electron has been transferred over here. So we've got s and p over here. Now we will do what? We will fit in 2 more electrons of what? Chlorine in here. And when I fit in chlorine in here, this becomes sp hybridized. What does it become? Sp hybridized. This is called as sp hybridization. Okay, sp hybridization, wherein the contribution of s is 50% and the contribution of p is 50%. Whenever the contribution of s is very large, like in this case 50%, s electrons of s are very close to what? To the nucleus, and hence the electronegative character becomes more or is greater in sp hybridized molecules. So sp hybridized molecules will tend to be more electronegative than the sp2 and sp3. Okay, so this is sp hybridized because in this molecule, 1 orbital is being contributed by s and the other one is contributed by p. So this is sp hybridized. Now for the second example which we had seen, that was boron trifluoride. So in boron, atomic number 5, electronic configuration 1s2 2s2 2p 4 plus 1 5, right? And therefore we'll write like this: 2s2, okay, 2s2, then 2p1, that means 2s2 is 2 electrons in here. P will obviously have 3 orbitals, px, py and pz, and 1 electron is already present. So what we'll do, we will shift this electron over here because we need 3 unpaired electrons in order to combine 3 unpaired electrons of fluorine. So we will shift it over here. The orbitals energy will become equal, okay, or similar, after which 1 electron is going over here, after which the unpaired electrons from fluorine can come and combine over here to form the sp2. Okay, this is spx and py. So s, 1 orbital of s, p, 2 orbitals of p, sp2 hybrid or sp2 hybridization. So the stability of BF3 was not being Octet rule was not able to be was not able to explain the stability of BF3, but hybridization is able to explain the stability of BF3. It is sp2 hybridized. The contribution of s is 1 orbital and with 2 orbitals of p. So if you talk in terms of percentage, the 33% of contribution is coming from s orbital. If any one of you has not understood this, it's simply like the total are 3 corresponds to 100%, okay, out of which we have to find out the contribution of s. So 1 s orbital is there, that will correspond to how many? Unitary method, 1 into 100 divided by 3. So answer is 33.33%. So that's why I said the contribution of s in this case is 33.3%. So in the previous case, s was 50%, right? Half of the contribution was by s, and I told you when contribution of s or percentage s character, as you know it, the percentage s character is how much? 50%, and in this case the percentage s character is 33%. So that one will be more electronegative. That means sp will be more electronegative, sp2 will be less electronegative. So what we are going to do now, you are going to solve the similarly you're going to solve it for PCL5 and SF6. And if you are not able to solve, just comment in the comment box and I'll get back to you on PCL5 and SF6.